Hi, dear students. Today we are going to continue for lesson 6 and we will cover pages between 163 to 165. The topic is percentage yield and percentage purity of products. First of all, we are going to focus on percentage yield. Um, in many times, we cannot expect that how much we can get product from a chemical reactions. Okay, in the laboratory, when we are making a when we are going to make a chemical reaction, so we cannot predict accurately what how much we can get as a product. If you remember last session we tried to calculate and find how much we can get as a product, but this is not happen accurately and this is not happen uh, correctly in all the time. There are many reasons, as your book mentioned. I put it here, the three reasons. uh, first is reaction may not be totally complete. That means the concentration between reactants or the type of chemical is different, and some of them are not interested to react each other. So it depends on the situation whether a chemical reaction become a complete or no. And also during a chemical reaction, we will face a many error. The errors can be come from human errors or equipment's error. Sometimes you are measuring your reactants or products, then just you face the error from the equipments. This error cannot be removed at all. There is an error, but yeah, scientists always try to find a correct value and accurate result. Another reason is chemicals may be lost during reaction, transferring, or separating. Uh, as you can remember that before we learned about separating or uh, transferring the chemical or titration, if you remember. So when we are going to transfer the chemicals in the laboratory and we use dishes, so these dishes may lost some chemicals, or maybe uh, some chemical reaction produce gas, and the gas leave the chemical reaction. So these there are a few reasons that maybe we cannot get accurate product. So the way which we can calculate the percentage of yield, there is a definition for this equation is percentage yield is percentage of the product which you can get obtain, that is actual, it's a real, compared to the theoretical or predicted yield based on the mass and number of mole. We can predict, we learned before how we can predict, how we can measure the yield of products, how much product we can get. But if in laboratory you can get another or same, no different, the product which can be defined as a obtain our actual product. That means you can get in real situation in laboratory. So this is the if you make it a division and times to 100 is the percentage of yield. There is one example from your book. We can look at after look into the this example. Heating 12.4 gram of copper 2 carbonate in a uh, crucible produced only 7 gram of copper oxide. What was the percentage yield of copper 2 oxide? So this is the reaction. Okay, we can write the reaction based on what they give from the question, and also uh, we are not focusing on the CO2, the carbon dioxide, because as the question asks, they just give some data for copper carbonate, this one CuCO3, and copper oxide CuO. First of all, we need to calculate uh, how much gram we can get from this reaction if we have 1 molar. Okay, if we have 1 mole for each of them, because this is 1, here is 1, here is 1. Okay, and this equation has included 1 copper carbonate, and production is 1 mole copper oxide and 1 mole carbon dioxide. For each 1 mole we can get 124 gram for copper 2 carbonate and 80 gram is copper oxide. This value can be taken from the periodic table. We learned before how we can measure. It's a very simple way to calculate the molar mass of a compound. Okay, we can get this, and at the same time we can divide to 10 because our the data we can the data we receive from the question is around 7 and the another is 12, so these are very big value and it might be not suitable. So we divide to 10, same ratio. Okay, we need to find the same ratio. If we divide to 10, we can use the same relationship, same ratio to find the same value. Therefore, heating 12.4 gram, that is here, of copper 2 carbonate should have produced 8 copper 2 oxide. Okay, means if we divide to 10, 124, if we divide to 10, that means we can get 12.4 gram copper carbonate, and if we divide to 10 we can get 8 gram copper. Okay, this is the same ratio, no different, but we are going to have this number, lower number. So we use this equation as I said in previous slide. So expected yield, the question said what percentage yield of copper oxide, that means this one. Okay, we are going to this also. Now we are not looking for CO2 or this one. Expected yield is 8. Okay, this one, this is expected, that means we calculate, it's a theoretical. Actual, that means in a real, is 7 as the question said. Okay, the question said 7, and this is 7. So after that we have expected yield, we have actual one. So finally we use the equation, put actual one which is 7, we put predicted or expected which is 8. Then we run the calculation, the answer will be 87.5%. For percentage purity, because the topic is has included two, percentage yield and percentage purity, now we are going to focus on percentage purity. In a similar way, percentage purity can be calculated like percentage purity equal mass of pure product divide to mass of impure product. Impure product, that means whole of your chemicals, okay, all your chemical which is consist of pure products or other products or other compounds is mass of impure product. Mass of pure product, that means the compound that you are looking for, it's only one pure product, then times 100. Percentage purity indicate the mass amount of pure substance present in a sample. In a sample means the whole products, okay, the total product. Here we are going to have one example. An initial crude sample of copper is prepared industrially and then tested for purity. Okay, a sample of 10.15 gram of crude copper is analyzed by various methods and shown to contain 9.95 gram of copper, with the remaining mass being made up of other metal. So if the question asks for purity, this is simple because we are using the only copper, okay, only copper which is pure, your pure compound, pure substance, put it here, this is pure, and the sample, okay, the total product is crude copper. So impurity, our total product is 10.15, then times 100, then you can run a calculation. So this question is very simple. Just you need to replace the number in an equation. You need to practice and repeat the equation, then replace the values. And that's all for today. Please read the questions. I put 3 questions for you, and you can practice and memorize better for this topic. And these are question number 2. You can pause the video and write down the question, and please give the answer and submit Google Classroom. I will check. Thank you so much. Take care. Stay safe.